So they're controlling the feed rate throughout the cut to ensure that we have a consistent level of force throughout the whole component. The end result is we have two features that are exactly the same. We have one program that runs at about 9.5 minutes and another program that runs at about 8.5 minutes. And that's exactly the same program. The only difference is one has been optimized.
We're here at NMIS in Glasgow, and we're going to look at what looks like quite a generic aluminium part, but it's really not. We'll talk to Conor a little bit later about exactly why it's not, but we're here at NMIS. You're from Productive Machines, Thomas. Now, who are Productive Machines?
Productive Machines, we solve problems in high-value manufacturing, such as low sustainability, low productivity, process-induced problems such as chatter instability, and time wasted through trial and error.
Okay, and this is we're here at the centre of excellence manufacturing, which is obviously those problems are they hit probably a lot of machine shops up and down the UK and in Europe. Why are you guys members of NMIS?
Well, collaborating with NMIS is brilliant for growing companies like ours, because we get to take advantage of these world-class facilities, and it's easy for us then to connect with complementary companies like QUICKGRIND.
And why do you think QUICKGRIND complements Productive Machines?
Well, if you've invested in high-quality cutting tools like QUICKGRIND, then it only makes sense then if you want to produce best quality parts, so our optimization services can add to that.
And it's not just the top-end products, cutting tools from QUICKGRIND, it's the knowledge and experience that they offer too. Because you guys are up in like the optimization space. These guys are all about getting the right tool first time and picking the right parameters first time.
Yeah. And well, if we work together as well, it gives our end users the best chance of producing the best quality parts first time as well, rather than all the iterations that they would normally have to go through with trial and error.
But exactly why are QUICKGRIND such a complementary partner to Productive Machines?
Well, using from QUICKGRIND, you can get a really good, nearly 100% process, but by adding in our optimization services, it enables you to squeeze every possible bit of benefit out of what you're doing.
Okay, and we're going to talk to Conor right now about exactly how you squeeze out the absolute last little bit out of that demo on a beautiful aluminium part on this DME 125. So Conor, this is the demo we're looking at right here, but to me it looks like a standard aluminium demo.
Yes, and that's intentional. We produce a lot of proprietary components, or we work on a lot of proprietary components that we're not allowed to share. So we produce these demonstrators so that we're allowed to share technology and show what we are capable of. The specific purpose of this demonstration is to show a lot of our digital capability and how we can optimize machining through machining dynamics.
So even though the part looks quite generic, there's a lot of technology that's gone into the optimization of it and the process, which unfortunately you can't see with the static part. Can you talk me through the process by which you optimize the part?
Yeah, so we started off with, as most companies do, we select the cutter and we take the parameters from the book. QUICKGRIND are great for this because I can just phone up Mark and I can ask him, what cutter do you think is suitable for this job? What will give us the best material removal rate? And what parameters should I start off with? And that gets me a good way of the way there. So I know I've got a pretty good program to start off with straight out of my CAM system. We then worked with a company called Productive Machines. They provide a lot of optimization technology. So they do analysis on the material. We do cutting force trials. We do tap testing to measure the frequency the tool wants to resonate at. And they also take our NC code and they run it through their system, which generates an optimized output. So they're controlling the feed rate throughout the cut to ensure that we have a consistent level of force throughout the whole component. The end result is we have two features that are exactly the same. We have one program that runs at about 9.5 minutes and another program that runs at about 8.5 minutes. And that's exactly the same program. The only difference is one has been optimized.
Which is that's almost like a 10, 15%, I can't do the maths in my head,
about
but like a 10,
saving.
10% saving.
Yeah.
Just by changing what did you actually change? What's the process? So you create the NC file for this side.
Yeah, and it's particularly interesting that we're using an adaptive clearing strategy. So we've used NX to generate an already quite efficient toolpath. What Productive Machines have done is they've looked at the cutting forces. So we have a 15mm deep engagement and we have a consistent engagement throughout. But as you enter corners and you exit corners, you have an increase in your amount of engagement based on the angle of that engagement. So that increases your force or decreases your force as you come out of the cut. So they look at the overall force through the whole toolpath and then they pick a level and they increase your speeds to get up to that level or decrease so that you don't put undue stress on the component. They can also do optimization for non-cutting moves. So they know exactly when you've retracted away from the material and they can make it go to a G0 on the rapid transfers. So you can get a lot of a lot of time saving just straight out of optimizing your NC
so you're
program.
Squeezing that last little bit out of the NC file. But
surely,
as we discussed earlier, the first step that the business will take is you go to a cutting tool vendor like QUICKGRIND who will tell you what end mill you need and what parameters run at. Surely that's good enough for most people. Why do you need to squeeze out these last bit of optimizations? Who would want to do that?
Basically anyone that is producing a lot of swarf through their process. If you've got a lot of material to remove, you want to make sure you're removing it as efficiently as possible, but also by levelizing the force you can improve your tool life, so your tool might last longer. What you might also find is those nominal parameters might correspond with the frequency mode of your machine tool, so your machine might want to vibrate at those specific parameters. Your initial instinct might be, oh, it's getting chatter, I'll slow it down a little bit. But actually, if you look at what productive machines do, where they measure the stability lobes of the machine, you might find that just speeding it up a little bit will give you better stability and better productivity and better tool life.